All right, so this is the key to the worksheet on using properties of logarithms to expand. So notice the word expand here. So to expand the logarithmic expression as much as possible, and where possible, evaluate logarithmic expressions without using a calculator. All right, now in on this worksheet, you're going to need a couple of properties of logarithms. So let's kind of review these particular properties that you're going to need for this worksheet. Okay, so the first one is going to be the product rule. So the product rule for logarithms. And so basically the product rule says this: if you have the log of a product, let's say m times n, some base b, then I can expand this and I can write the log of this product, m times n, as the sum of the log of those factors. So the log of m base b, that's base b right here, plus the log of n base b. All right, so you can write a product as the sum of the logs of those factors. The quotient rule, you need the quotient rule as well. So remember quotient division. So the quotient rule says if you have the log of a quotient, let's say m divided by n, with some base b, then I can expand that as the log, as the difference, I'm going to write it like this, the difference of the logarithms. So the log of the numerator with some base b minus the log of the denominator with some base b. All right, so be careful when you're dealing with subtraction. Remember, subtraction is not commutative, so the order matters. So it has to be listed as the log of the numerator minus the log of the denominator. And notice that in each of those cases, make sure your bases are listed, okay? Unless it's base 10, a common logarithm, in which case you don't have to put the 10. If it's a natural logarithm, remember you're going to use the symbol ln for that case. All right, so let's look at, oh, and also the other property you're going to use is the power rule. So let's review the power rule. So the power rule says if you have the log base b of some of m raised to the n power. All right, so the exponent only applies to the base m here. Then I can write this as the exponent times the product of the log of m base b. So in other words, I can write it as n times the log of m base b. So you can write the exponent as a product of that exponent times the log. All right, now as long as, keep in mind, as long as the exponent applies to only that base right here. Okay, so now let's look at number one. So number one, you have the log, and notice there's no base listed, so that's understood to be a common logarithm, base 10 right here. So the log of this product, 1000x, and you want to expand this. And all I want is the answer here, although you had to do some work, right? You have to show some work here. So you're going to write this as the, if you look at this as a log of a product, 100,000 times x. So you're going to use the product rule here. So you can expand it as the sum of the log of those factors. So you're going to say the log of 100,000 plus the log of x. All right, now remember the directions also said, where possible, evaluate logarithms without using a calculator. So if you notice, the base here is 10. So let's think about what the log of 100,000 is. Now that's something you need to automatically recognize that I can actually simplify this. And so remember how we did this. So we look at this and we ask ourselves, 10, remember this is 10 right here, 10 to what power is 100,000. So 10 to what power is 100,000? Well, the answer is going to be 10 to the fifth power, right? So 10 to the fifth power is 100,000. So this is 5 right here. So this right here becomes 5. So this would be 5 plus the log of x, and you cannot do anything else. Those are not like terms, so you're done. All right, so the answer is going to be 5 plus the log of x. Okay, number 2, you have this. And number 2, you have the natural log of e to the, and let me go ahead and put that in parentheses, the natural log of e to the 15th power divided by 8. All right, now notice I'm taking the natural log of a division, right, a quotient. So I'm going to use the quotient rule first. I'm going to use the quotient rule first. So I'm going to change this to a subtraction. So this becomes, let me go ahead and do it here. This becomes the natural log of e to the 15th minus the natural log of 8. Now look at this right here. I can go further with this because I can use the power rule. So the power rule says I can take that exponent and write it as a product. So I can take 15 here, and I can write the natural log of e to the 15th as 15 times the natural log of e, and then minus the natural log of 8. Okay, now you need to recognize when it is possible to simplify, when it is possible to evaluate log expressions without using a calculator. In this particular case, you need to remember what the natural log of e is. So let's think about this, the natural log of e. Some students, when they look at this, if they don't automatically know that that is a 1 right here, this is supposed to be equal to 1 right here, then what some of them will do is this. They'll rewrite the natural log. Remember, natural log automatically has base e. So they write this as log base e of e. So the ln means the same thing as log base e. And then, remember, we did this. So now we're going to change this to an exponential equation. So we have the base, which is e, raised to what power? So e raised to what power is e? Well, e to the first is itself, right? So that's how we got that 1 here. So then what that means then is this right here where we have 15 times the natural log of e, that really means 15 times 1 minus the natural log of 8. And then 15 times 1 is 15. So I get 15 minus the natural log of 8. And you cannot simplify the natural log of 8. So that's your answer. So 15 minus the natural log of 8. Okay, let's look at number 3. Number 3, we have this. We have the log base b of x to the 8th power times y. All right, now, hopefully you can recognize that, see, this is a product, right? So since as a product, you're gonna change this to an addition problem. You also see an exponent right here, right? So you're also going to use the power rule at some point. So the first thing you're going to do, though, is you're going to use the product rule first. Don't put the 8 out in front, because remember, in order to use the power rule, the exponent has to be applied to the whole base here. And if you look at this, I'm taking the log of all of this. So if I were to pull that 8 out in front, I would have had to need the 8 being here. Okay, but 8 is not being applied to this whole part right here. It's only being applied to x. So you always have to be careful. You always have to know how to apply these properties. So the first thing you're going to do, though, is you're going to use the product rule. So this becomes the log base b. Notice I'm writing the base. Always make sure you write things mathematically correct. So the log base b of x to the 8th plus the log base b of y. And then I can go further with this because I see an exponent right here. So I can use a power rule. So this becomes 8 times the log of x base b plus the log of y base b. And that is it. That's all you can do. You cannot simplify anything else. You are done. So that is number 3. So number 3, the answer is going to be 8 log of x base b plus the log of y base b. And make sure as you're writing this that your bases look like a subscript. So and see where x is? So x is aligned with that log right here with log. The y is aligned with log, and the base is listed as a subscript. Make sure you write things mathematically correct. Now, I should not have put the 8 way out here, but that's fine. That means 8 log of x base b plus the log of y base b. I should have written it a little bit closer, but that's okay. All right, so that is number 3. Okay, let's look at number 4. Okay, number 4, we have the log base d of the square root of x divided by r to the 5th. All right, now, notice I'm going to use the quotient rule first, and then I'm going to have to use the power rule at some point. So using the quotient rule first, this becomes the log of the square root of x base d minus the log of r to the 5th base d. Okay? All right, now I'm going to use the power rule. The square root of x, remember the square root of x, remember to put that here. The square root of x means x to the 1/2 power. All right, so remember always, whenever dealing with this situation here, always make sure you know how to change a radical expression to a rational exponent. All right, so now this right here becomes the log of x to the 1/2 base d minus the log of r to the 5th base d. And now I can take each of those exponents and use the power rule and write as a product. So then this becomes 1/2 times the log of x base d minus 5, the exponent, pull the exponent out in front, 5 times the log of r base d. And that's your answer. All right, so number 4, we're going to have 1/2 times the log of x base d minus 5 times the log of r base d. Okay? All right, so that's what it means to expand. So let's look at number 5. Number 5, we have this situation. There's number 5. We have the log base b of the cube root of s times t to the 7th power. So that's the numerator. The denominator is r cubed. So in this case, hopefully you can see that you're going to use all 3 properties. You see a product, there's a product in the numerator, you see a quotient, you see a division, and you see some exponents, right? All right, now, so let's go ahead and, so the first thing you're going to do though is you're going to use the quotient rule first. All right, so let's go ahead and do that first. So there's going to be the log base b of the numerator, so the cube root of s times t to the 7th, minus the log base b of the denominator. Notice each time I wrote the base as well. And then if you cover this part here, let's say, you can recognize that I can expand this further because that's the log of a product. And also keep in mind that the cube root of s, hopefully you recognize that, the cube root of s is s to the 1/3 power. Okay, so that's important to know. So right here, I'm going to use the product rule. So I'm going to write this as an addition problem, as a sum of 2 logs. So this becomes the log of s to the 1/3 base b plus the log of t to the 7th base b. So that's what this is right here. So that's this. So the log of this product is the sum of the 2 logs, minus, and then the log of r to the 3rd base b. And then all you do at that point is just use the power rule. So this becomes 1/3 times the log base b of s plus 7 times the log base b of t minus 3 times the log base b of r. And that's it. Cannot do anything else. So that was number 5. Let's look at number 6. So number 6, you have the log base 3 of 27 fifths. Okay? So notice I'm going to use the quotient rule. So that becomes the log base 3 of 27 subtract the log base 3 of 5. Okay, now at that point, just like we mentioned earlier, you need to recognize when you can simplify or evaluate a log expression. See this right here? Let's think about the log base 3 of 27. All right, so I'm going to put equal box here or x, whatever you want to use. Now I'm going to change this to an exponential. So you're going to ask yourself, 3 to what power? 3 to what power is 27? Well, all of you know that 3 to the third is 27, right? That's a 3 that goes here. So that's 3. So then what that means then is that this I can write as 3, because 3 to the third is 27, minus the log of 5 base 3. I cannot simplify the log of 5 base 3. There, 3 to no whole number is 5. Okay, so that's it. There's your answer. So you get 20. Oh, I'm sorry, that's not 27. Excuse me. That was supposed to be 3, right? All right, so let me go ahead and just rewrite this over. 3 to the third is 27. So that's 3 minus the log of 5 base 3. So that's the answer. All right, number 7. You have the log of 25a base 5. All right, so notice that in number 6, you had a quotient, so you used the quotient rule, so you changed that to a subtraction problem. So we the difference of the two logs. This is a product, right? So you can use the sum. So it'll be the sum of those two logs. So use the product rule. So this becomes the log of 25 base 5 plus the log of a base 5. And at that point, just like we did in number 6, hopefully you recognize that the log of 25 base 5 is 2. Hopefully you saw that, because if you think about it, you have the log of 25 base 5. So if you think about it, 5 to what power is 25, right? So 5 to what power is 25? Well, the answer is 2. 5 squared is 25. So you get 2 plus the log of a base 5. And there's your answer for number 7. Number 8, you have the log base 2 of 8x divided by 5. All right, so at this point, you're going to recognize that you can use the quotient rule, and you're also going to use the product rule, right? Because in the numerator, you have a product, a times x. So let's use the quotient rule first. So you have the log of 8 times x base 2 minus the log of 5 base 2. And then I'm going to use the product rule here. So that becomes the log of 8 base 2 plus the log of x base 2 minus the log of 5 base 2. And then you got to ask yourself, can I simplify anything? Can I evaluate any of these terms right here? Hopefully you saw that you can evaluate, that you can simplify the log of 8 base 2. So let's think about that. The log of 8 base 2. Hopefully you recognize that 2 to the third power is 8, right? So that should be 3. So remember, 2 to what power is 8? Well, the answer is 3. So this right here becomes 3. I can write this as 3. So you get 3 plus the log of x base 2. And you cannot simplify the log of 5 base 2. 2 to no whole number is 5. So you get the log of 5 base 2. And so that is number 8. Okay, let's look at number 9. So number 9, we have this. All right, so this would be number 9. All right, so number 9, we have this problem. So number 9 is the log of x to the 7th divided by y to the 4th. All right, so that was not a difficult one, right? Let me go ahead and put that in parentheses. Okay, now notice the base is 10. So that's a common logarithm we're dealing with. All right, notice in this case, I'm going to use the quotient rule. I'm also going to use the power rule, right? So I get the log of x to the 7th minus the log of y to the 4th. And then one more step and you're done. So you're going to use the power rule. So you're going to write the exponent as a product. So it'll be 7 log of x minus 4 log of y. All right, so that was a simple one. Number 10. Okay, so number 10, we have the log of x y to the 5th raised to the 3rd power. Okay, now I'm going to do this in a couple of ways, but what I want you to recognize is, see this 3 out here, that exponent, and you also see an exponent of 5, right? And you also see an exponent of 1. But that outer exponent applies to this whole base right here that you're taking the log of. So then that means that if I want to do this now, which is what I would do, then you would use the power rule at that point. So you're going to take this 3 and you're going to write it as a product. So this becomes 3 times the log of x y to the 5th. So that's where we're at. Okay. Now at this point you are to recognize that I'm going to use the product rule. Be careful. Don't bring that 5 out in front and write this as a 15. 5 times 3 is 15, because 5 is the exponent only of the y, not the x. So you have to be careful. Okay? I brought the 3 over, wrote as a product, because 3 applied to the whole base. My whole base is this. See that I'm taking the log of? I'm taking the log of all of this. The exponent is 1 now, not 5. All right, so the first thing you're going to do is you're going to take the product rule. So this becomes, and it's going to be 3. Don't forget to write the 3. So it'll be 3 log of x plus 3 log of y to the 5th. And notice right here, see this exponent is 1, so I'm done. Now this exponent is 5, so I'm going to use the power rule, write it out in front. So this becomes 3 log x plus 5 times 3 log of y, and 5 times 3 is 15. So I get 3 log x plus 15 log y. And so that's the answer there. Now I want to remind you about something. Someone else could have done it this way. So you have the log of x y to the 5th raised to the 3rd power. Okay, so I want to remind you about this fact. So you see, remember one of the properties you learned in a previous course was that when you have I'm going to write it like this. If you have, let's say, x squared raised to the 3rd power. When you had x squared raised to the 3rd power, remember when you have a power raised to a power, when you have a power raised to a power, so there's a power to a power rule, you multiply exponents. So this becomes x to the 6th power, right? And then some students, without having to memorize this, they think about it this way. Well, the outer exponent is 3, so that means I take x squared and I multiply it by itself 3 times, right? And so when you multiply like bases, you add exponents. So 2 plus 2 plus 2 is 6. And so regardless of which approach you use, you get the same answer. Now, if this was 300, then obviously you would not want to do it this way. You would want to use the fact that when you have a power raised to power, you multiply those exponents. Same thing applies here. So you have x to the 1st raised to the 3rd power. Let me go ahead and put that here. So you have x y to the 5th cubed. So what you have here is x to the 1st cubed, right? and you have y to the 5th cubed. And so you're going to use a power to a power rule. So 1 times 3 is 3. So it becomes x cubed. And then 5 times 3 is 15. So you get y to the 15th. Meaning that then I can rewrite this as the log of x cubed y to the 15th. And then I take the log, I'm going to use the product rule now. It becomes the log of x cubed plus the log of y to the 15th. And then using the power rule, this becomes 3 log x plus 15 log y. And notice, regardless of which approach I used, either this or this, most students would probably use this approach here. You get the same answer. Okay? All right, so that was it. So that is the key to the worksheet on expanding these logarithms.